We have the topic of titration, and these are your vocab terms. First off, a titration is a controlled addition of a solution of known concentration to an unknown concentration. Next is a burette. That's an equipment used to add the solution of known concentration. Next is a titrant, which is the solution of known concentration. Then you have the analyte, which is the solution of unknown concentration. You have the indicator, which is a weak acid or base that changes color with or when pH changes. An endpoint is when the indicator changes color, and this denotes that the titration is complete. The equivalence point is a point where moles of acid equals the moles of base.
This is the titration equation. This side is for the analyte and this side is for the titrant. N is the number of equivalents, M is the molarity, and V is the volume. Example problem number 1. If it takes 54 milliliters of 1 molarity NaOH to neutralize 125 milliliters of an HCl solution, what is the concentration of the HCl? Since the NaOH is the titrant because it has a known concentration, 54 milliliters and 1.0 molarity would go on the right, as well as a 1 because there's only one OH ion in NaOH. That would be equal to the analyte, which is of unknown concentration. So the 125 milliliters, and X for the concentration, and there would also be a 1 on this side because there's only one hydrogen ion. When you multiply that together, that would give you 125X equals 54. You divide each side by 125. That would give you X equals 0.432. And with significant figures, that would round to 0.43. Practice problem number 1. If it takes 25 milliliters of 0.05 molarity HCl to neutralize 345 milliliters of NaOH solution, what is the concentration of the NaOH? Pause the video and then come back to watch me solve the equation. Okay, since the HCl is the known concentration, that would be the titrant, so it would go on the right. And the NaOH would go on the left. Once you multiply them together, that would give you and when you divide, this would equal 0.0036 molarity, or 3.6 times 10 to the negative third molarity. Practice problem number 2. Titration reveals that 11.6 milliliters of 3.0 molarity sulfuric acid are required to neutralize a 25 milliliter NaOH solution. What is the molarity of the NaOH solution? Pause this video and then solve the problem and come back to see the solution. Okay. Since you know the concentration of the sulfuric acid, that would go on the right. And the NaOH would go on the left. When you multiply that, you get when you divide by 25,
titration curves. Some important things to remember. The volume of titrant added is on the x-axis and pH is on the y-axis. Equivalence point is located directly in the center of the sharp increase in pH. A pH that is less than 7 is considered acidic. A pH that is greater than 7 is considered basic. This is what your average titration curve will look like. You should have a better quality graph on your paper. On that paper, I want you to label the acidic region, the basic region, and the equivalence point. And then I want you to tell me what the pH is at the equivalence point and how much titrant has been added at the equivalence point. Pause this video and come back when you're done with that. So the acidic region should be located below where the pH is 7, so that should be about from here down. And then the basic region should be above 7, so about right there. The equivalence point is in the middle of the sharp increase, so that should be about right here. And then the pH at this point is about 7. The amount of titrant added on your paper should be 1.000 dm3.